Very good evening, everybody. Welcome back. How are we today? Another day, another opportunity to learn more and keep expanding, keep increasing our knowledge base. It is it is not only for you, but also for us. We also do some amount of preparation before we get into this phase here. So it is not just the half hour that we are, connected at the same time, but also at least the same amount of time beforehand we connect and we discuss what is to be covered or what is to be communicated to the participants through this dialogue, which is the interview session. So, yeah, please do take adequate benefit out of it. Barney is not available today. He may join. He's busy with an important call, so he may join at a later point of time. Otherwise, also, as they say, the show must go on. So the topic for today is knife base, and we'll be discussing about the knife base, the Bayesian classifier, and then within that, we'll also be discussing about the various hyperparameters. So there's only one person to be interviewed, Sharath. Everything comes to you. I have a very easy job of, only asking the questions and troubling you. So can you briefly tell me about what knife base is and what is its purpose? What is its advantage in context or vis-a-vis other classification or other predictive models?
Good evening, everyone. Thank you so much, Nathan. I get the opportunity to answer all the questions, right? So I look at that as a better side or an advantage for me. Good evening, everyone. Good evening, all the audience who have joined us, and welcome back to the channel. Today, we are going to discuss about the knife-based classification model, or knife-based model rather. It's a shallow technique. The question that I've received from Nathan is, what is knife-based algorithm and where specifically we use it? What are the basic different advantages or pros and cons with respect to knife-based algorithm? So when we talk about knife-based, let me just try and share my screen. All right, so this is our mind map. You might want to refer to the mind map. Whenever you're trying to learn things, it's always good to have this kind of overview. It will enable you to try and do the correlations, cross-mapping of different topics. So here under data mining, we have supervised learning. And when we talk about supervised learning, it is all about predicting the outputs. So these are predictive models, right? So we need to try and predict the output. And labeled data will be there, and we try to define the pattern. But the scenario is we may not always try and find a mathematical equation which can express the relation between y and x in an effective way. For example, what if output variable is non-numeric? Isn't it? So I cannot simply come up with a mathematical expression. Arithmetic operations, basically, that's what I mean. So in these kind of scenarios, we need some alternative approaches which can actually allow us to try and estimate a non-numeric output given factors that are influencing those conditions. So in these cases, we have shallow machine learning models that we can use. And these shallow machine learning models, right, are primarily categorized into three different approaches. The first approach is that we are discussing today is knife-based. And it's a very popular algorithm. You probably have learned it in your primary education itself before your 10th grade. You probably will be familiar with knife-based probability concepts. In simple cases, we are trying to understand conditions-based probability, or you can say conditional probability. So what we are basically saying is, I need an output to be calculated, but there's a condition. The condition is that the values of your input factors are these: x1, x2, x3, x4, x5, so on and so forth. Given these conditions, what can we say will be your output? So chance of the value given these input factors, right? So that is your conditional probability. So we can write it as probability of your output category, one of the categories, given all these input factors. And when we talk about this conditional probability, if I basically try and write it as two events, the second event given the first event, we will generally write this as probability of A and B, joint probability basically. I'll say A and B divided by probability of A. So given the probability, right? So what is the joint probability that we have? You can also express this as probability of A, probability of A given the B conditions, and then probability of your overall B. So this is another way to represent your knife-based algorithm. And knife-based is very, very, very popularly used in identifying whether your email is a spam or a ham case. Okay, very, very commonly applied use case. The advantage is that you will try to measure the probabilities of your outcome based on input variables. So it's a pretty simple technique, hence it's called as a shallow machine learning algorithms. And even if you have large amount of data sets, the knife-based seems to be working very well because it's ultimately the probability that we are trying to calculate. This is basically the overview of your knife-based algorithm. And when we talk about the knife-based, the application also have mentioned, but yeah, it is not restricted to that. We can also try and use the knife-based algorithm to predict the numeric output as well. And anyways, you have non-numeric output scenarios that I just explained. Though we have a disadvantage with knife-based, which is called as zero probability problem. We'll talk about that in detail again, right? So we'll try to continue that, more about that discussion. Yes. Hope that answers the question.
Yeah, thank you, Sharath. Yeah. So you mentioned specifically about the ham and spam application. I'm assuming that is because the ham and spam application is because we can, using the textual data, we can create a large quantum of features. Each word becomes a feature. So does it, am I to understand that the Bayesian classifier or knife-based works well when the number of features are very high? Is that the thing about it? If it is lesser features, how would it behave? Could you just throw some light on that?
Yes, very correctly mentioned, Nathan. That's the exact point. Knife-based algorithm, as we discussed, right, conditional probability based calculations, it definitely works well when you have more features, because each feature's effect in getting the output should be captured in the right manner, and knife-based is able to do that very, very appropriately well. You can also apply this with respect to less number of features as well, but it has an advantage when you have large amount of values. And the formula itself is a very simple algorithm, so it really does not have a heavy computational burden on large columns.
All right, thank you. So we also are aware of some of the variants of the knife-based. So could you throw some light about those aspects as well? What are the variants?
Absolutely, absolutely. So whenever we talk about these shallow techniques, right, a lot of default interpretation is that it works only for output variables which are non-numeric. But see, when we are trying to apply a concept in order to capture non-numeric outcome, then the same concept can be captured for or used for capturing numeric outcome, right? So it's not that difficult. So knife-based algorithms are used as regressors as well, right? And of course, we are talking about classification concept, right? Classifiers. And knife-based predominantly comes in three variants. Let me show you that. Yeah, this is the case. So this is the mind map, or you can say cheat sheet, which allows us to identify what are the various functionalities that your knife-based algorithm has from sklearn. The package itself is called as sklearn.knife base. And it has variants, right? So Gaussian knife base, multinomial knife base, and we also have Bernoulli knife base. All right, so these are the three variants. You can also try and go to the official documentation here. I would say sklearn knife base. Right, you can directly go to the sklearn.org folder. And you can see these are the various different options that we have with respect to knife-based implementation. If I go to the first one, right? So if you talk about Gaussian knife base is basically algorithm which is typically used for the target variable which follows continuous output, Gaussian right distribution. When you have multinomial data, that is your output variable contains nominal data, right? In such cases, we go for multinomial knife base, right? Multinomial distribution. We also have complement knife base, and we also have the Bernoulli. The three important knife-based algorithms are Bernoulli's, Gaussian, and multinomial. Multinomial is what we were talking about with respect to classifying an email into spam, ham, or multinomial, right? So it could be important folder, it could be promotional folder, it could be spam, it could be various other folders that you see in your Gmail, for example, today. So given the various inputs, that is the content of your email, where should I place that email? Should it go into spam folder? Should it go into your inbox? Should it go into promotion? Should it go into social media folder? Should it come into the important folder? Right. So this kind of classification is something that it learns. Right. So these are the different variations that we have, and Bernoulli is typically applied for your binarized output, binary value. Okay, so that is basically how it works. Yeah.
Yeah, thank you, Sharad. So I was actually reading the the website that you've opened about scikit-learn, and getting to the details. So that brings me to the next question. So what are all the various, because hyperparameters is something that we'll be discussing about. So what are the hyperparameters that are pretty much common, and how do you tweak those hyperparameters to improve the model? Can you throw some light?
So the most important hyperparameter with respect to knife base is something called as Laplacian smoothing. Okay, which is basically your statistical measure or constant that we use to ensure that we don't get zero probability case. And this is basically called as alpha. Okay, now when we talk about the multinomial base models, the problem that we will encounter is with respect to something called as zero probability. Okay, zero probability case. What does that zero probability case is all about? See, what we're trying to do is we basically try and build the input features data set. So this could be X1, this could be X2, X3, so on and so forth. And you'll have your labeled data here, right? So output variable is there. It could be your pass fail or spam ham scenario. Now we are saying that the spam or ham class that we are trying to detect should basically be depending on the values that we have in the input factors. Say, for example, if you talk about email would contain many keywords. So given bunch of keywords, whether it is to be detected as ham or spam, that's the logic that we are trying to constructed night base, conditional probability. Given these keywords, will it be having more chance of having declared as spam? So when you talk about this scenario, the biggest problem is when you try to build your model on historical data, you might have, let's say, some sample data. Right? So let's assume that there are 1,000 emails. Now, when you build the model, you're only taking the keywords which are coming from these 1,000 keywords, sorry, 1,000 emails. So you'll have a bunch of keywords. Let's assume that we have 2,500 keywords. We also call them as tokens. And our data set here will be converted into one hot encoded form. One hot encoded data, which contains whether basically ones and zeros, which representing whether the email containing that word or not. We're not worried about how many times it is existing. The same keyword might be existing multiple times. That is not the aspect that we are trying to capture here. We are thinking from a perspective whether the keyword is present in the email or not. Okay, for now, let's only discuss about that. So all the 1,000 emails, from those 1,000 emails, we were able to take 2,500 keywords or tokens. And with respect to these tokens or keywords, we are trying to define the probabilities for email being ham or spam. Till now, this is what we do. This is the training part. But what if you have to use this trained algorithm on new email? So as a user, you're receiving an email. And in this email, assume that there is a keyword which is not coming from this 2,500 keywords from the historical data. This is something new keyword altogether. Now, in this case, given this keyword, what can I say about the email? Should it be ham or spam? Now, from a training data perspective, by default, we will say that the keyword is not present. So if I try to imagine that there is a new word here that we are adding, let's assume that this is the new keyword that we are adding. So for this email, the word is not present. So, right. So this is your new email. This word is not there. And we have some words here, some words not there. Okay. Like this. The formula for knife-based algorithm says probability of the category of the email given some class, right? It says spam, for example. We will take all the tokens that are there in that email, right? These are your conditions. So when you talk about this equation, the formula says probability of your class. If from the historical data, we'll be able to identify the probability of the class multiplied by probability of this specific keyword in the class. So if you're trying to measure what is the chance of the email being spam, then how much influence this word has in those emails, right? So if I already have spam and this word is present in those spam, that means it has more weightage. The word has more weightage to declare an email as spam, right? So this is with respect to the first keyword. Similarly, I'll have the second keyword. Similarly, I'll have third keyword. So on and so forth. This is the formula that we have with respect to your probabilities. So P1, P of 1, X1, P of X2, P of X3. This is the dot product that we get. Now, when I take this information, I get some value here, some value probably here. With respect to the new word, the email does not contain that keyword, right? So that means by default, I'll assume that it is 0. So what happens to my class? What is the probability of class? If I substitute 0 here, everything becomes a 0. So the chance of that email being spam is 0. If it is spam is 0, then you can think of trying to calculate probability of class being ham. But again, is this keyword present in the email? Yes. But in the historical data, do you have that the word present in ham messages? No. None of these emails have the word. So even for probability of that word, for ham is also 0, because none of the previous cases that word was present. So even for probability of ham, it becomes a 0. Now, the email can either be a spam, or it can to be ham or some other class if it is a multi-class problem. But from this logic, we are trying to basically see everything as zeros only. This is called as zero probability problem. And this is the biggest problem that you will have in knife-based. Hence, the knife-based algorithm allows us to alter the outcome by using or by introducing a smoothing parameter, which is called as alpha. This alpha can be a float value. It can take any decimals as well. Okay, so this is with respect to your problem that we're facing. To overcome this problem, we have that Laplacian smoothing constant that we apply. This will ensure that we have non-zero value given to our equation, the formula. So probability of your email given the class will become non-zero, depending on the formula, right? I mean, we have plus k given here. K is the constant that we basically pass. So you'll never get zero probability in such instances. And this is the parameter which actually allows us to define the performance of the overall algorithm. Yes, so that's about the important parameters. So I've taken a little more time to explain things.
Yeah, sure. I understand. So quickly, I'd like to address a couple of questions that people have asked. One is Swapnil. So many times before Swapnil's question, I think there was Gautam. Yeah. So hi, sir, please make videos on monitoring and maintenance of machine learning models in production. So Gautam, currently we are in the process of completing our phase with reference to deployment. All right, we are on that phase. So once we have adequately covered most of the popular deployment techniques, then we will be, we'll be doing that. So our Saturday is going to be part of that. The Saturday series, as we call it, is part of that. So firstly, I would recommend you may try to take benefit from the existing thing that is going on every Saturday. Sometimes on Sunday we have it, the series that we have. So post that, we will definitely look up, and your suggestion is taken into advisement. We'll look into it. The next question is from Swapnil. Many times official mail goes to spam. Why it happens? What should we do to avoid this? Okay, so I don't quite understand by what do you mean by official mail. So are you talking about a mail from an official mail ID going to another official mail ID in spam? For instance, I and Sharath share a 360-digit mg.com mail ID, which is the core of it is Google Gmail, right? The core of it is Google Gmail, and on top of that, it is the official mail ID. So the firewalls and the protocols that are going to be put in place is going to ensure that it errs on the side of caution. Meaning, a mail accidentally going to spam is okay, but a spam accidentally coming in my inbox, because my inbox anywhere between 20 to 50 emails per day is what we receive. So if I'm getting spam mails as well into my inbox, that is going to be a little jarring note. But if there is somebody who sent me an email and this is my official email, then checking the spam is better. Every once in a while, as a policy, you must check your spam. The other thing that you could probably do is, if you are receiving mails from people and it is getting sent to a spam, generally when somebody sends a mail, they communicate. It's not like a mass mailing or a marketing mail. They say, I've sent you a mail. May I know your mail ID, sir? This is my mail ID. I'll send you a mail. So when you have such a conversation, it's prudent to also ask the sender's email ID, and if you have the time, immediately whitelisted before the mail is even sent, so that if it comes, it directly comes and sits in your inbox. So these are some of the precautions that you can take. The algorithm is not 100%, but it is very good. At least the Gmail algorithm is very good. The spam, 99.99% of the spam goes to spam, and 99.99% of the ham goes to ham. It comes to the inbox. So in that context, one or two cases, and then we are looking at a huge volume here. All right, we are looking at billions of emails that are being transmitted. So given that, you will have to, like I said, the algorithms are designed to err on the side of caution. All right, and therefore, if it is even slightly something new, or somebody is going to be looking like a spam, it'll try to give it as a spam rather than say that, okay, maybe if it is not a spam, give it your choice. So that's basically my answer to that. Karthik has a question: what could be the value of K, or could it be any value? Now, again, it is pretty subjective. I'll take that question, Sharad. So it is a pretty subjective kind of a thing. It is, again, with experience. Now, if you have really large amount of data, all right, and if you have large amount of features coming into play, then what happens is the probability values for each of those words is going to be that much lower. It is inversely proportional. If I have, let us say, 10 features, those 10 features are going to be repeated many times to be able to make the decision. But if I have 5,000 features, a particular word may appear in maybe 5, maybe 10, maybe 20 of the 2,000, 3,000 training records, maybe 20 times. So if you look at the probability as it is of that particular word or that particular feature, is going to be very low, 20 out of, let us say, 2,000. Now, if I'm going to put a very high K value, it is going to give enormous weightage to that particular word. All right. So in those kind of choices, we start with a very small, like Sharad said, you can have a float value as well. So you start with a very small value, and it's all about training and testing and validation. You have partitioned the data. You check different values of K. You slightly incrementally change or increase the value of K and check for it. And therefore, you will be able to get that. That's basically it. Sharath will probably just add one more input on that in a moment. More input variables increase accuracy. Will it also lead to overfitting? Overfitting it is an inherent property. More variables is, when you say more variables, I'm assuming you're talking about the features. All right. So yeah, more variables is definitely desirable because we are taking into a lot more thing. But yeah, there is obviously a point of inflection. All right. So we have policies in place when we are doing a Bayesian classifier. We have policies in place. Now, for instance, you may decide to choose 3-letter words or more. Then you choose probably, no, let me go for 4-letter words. All right. So through a trial and error, you will find that sweet spot, the point of inflection, which is going to give you the best accuracy for both train and test, the highest values. And then you find the ideal thing. Now, mails that my organization receives, let us assume, when I were to create a classifier to have the ham and spam, would probably require 5-letter words, or let us say the Indian context. All right, we like to type long words, all right, big words, and we are pretty educated. And the English-speaking population of our country is pretty educated. So we use bigger words, all right? So when there are bigger words, probably when you're dealing with an algorithm for India, you may have a bigger word kind of a scenario. Probably if you look at it in, let us say, some countries where English is not the primary language, they may use very simple words. I will come. Okay. Please, meeting at 6. These kind of mails, when they are using, that is when it is, that is where we have the scenario where smaller words would be required to have the classifier. So it is case to case basis. Sorry, I have, taken too much time here. So yeah. All right, then. Thank you so much. If need be, all right, if we get the feedback, if need be, we'll always have an additional session on certain topics, all right, if it is not completed. But again, feedback is essential. So please do leave your comments in the YouTube video itself, and then we'll look into it. Thank you so much, audience, for your time. Thank you so much. The regulars, I see a lot of people always make it a point to say hi every day. All right, and that's great. So keep visiting, keep coming regularly, and then we hope to, keep entertaining you with a lot of knowledge. Thank you so much.
Thank you, everyone.